Mathematics for class 10, unit number 5, sets and functions, exercise 5.3. First question. Here we have two sets. If set A have elements 1, 2, 3, 4 and 5, and set B have elements 2, 3, 6 and 7. Then draw Venn diagram for the A union B and second A intersection B. So we have to solve first A union B. We draw a box of universal set and having a set A. In Venn diagram, first judge all elements of set A and B and write common elements in such a way that they overlap two sets. We find that by comparing 1 is not in set B, 2 is common, so we write it here. 3 is also common and no 1, 4, 5 are not in the set B, so we overlap set B here as this is set A and this is set B. First write the common elements and then write all elements of set A and set B. 1, 2, 3 and 4, 5. Set B have elements 2, 3 and 6, 7. Since we have A union B, so we color the whole sets A and B, because A union B contains all elements, each and every elements of set A and B, but only in ones. That's why we write A overlap to B, because these elements 2 and 3 only occur once, because note that they are also member of A and they are also member of B, and individually when we write set A, we write them in set A and set B, but in Venn diagram we write only once. This is set A union B. This is Venn diagram of A union B. Next we have to find A intersection B. The pictorial diagram, Venn diagram of these two functions is the same because the sets are same. We write all elements in such a way, in a similar way, 2, 3, 6, 7, but here we color only common elements, which are 2 and 3, and this is the main difference between A union B and A intersection B. And we complete this question. Next we have to find question number 2. If set A have elements 1, 2, 3, 4, 5, 6 and set B have elements 3, 4, 5, 6, 7, 8 and set C is equal to 5, 6, 9, 10, then verify with the help of Venn diagram. First A union B union C, this is equal to A union B union C. We have to solve this. First we observe that A union B In these type of questions, it is better to find theoretically the all elements of common in both sets. So we have to observe 1 is not common, 2 is not common with 1 is not common in both sets, 2 is not common in both sets, 3 and 4, 5, 6. These 4 elements are common with set A and B, and 5, 6 is only common with these 3 sets. So 5 and 6, on the points of 5 and 6, these 3 sets are overlapped. So we can write them as, first of all, write the common elements in 3 sets, then write set A, set B and set C, then write these two. We have to write other elements. 3, 4 is common with set B, we write it here, and 1, 2 is not common in these 3 sets. So we have 3, 4, 5, 6, 3, 4, 5, 6 and 7 and 8 are remaining. Next, set C have elements 5, 6 and 9, 10. 9, 10 are not common in these 3 sets. We write here the operation A union B union C, and we shade them to show the answer, the solution. A union B union C contains all elements of these 3 sets, so we shade it as. Next, we have to find A union B union C. Similarly, overlap these 3 sets and write their elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This portion is very small. It's okay now. So A union B union C. For this purpose, this is one set, and we can show it as check. And then it is union with set A. Next we have A union B. So we color A union B first. These are all elements are common 3, 4, 5, 6 in the both sets, and then we color union C. This is how we color A union B union C. I think it's visible, more visible, and we observe that these are equal. Next part of this question is we have to find, second part, A intersection B intersection C is equal to A intersection B intersection C. Now we have to write all elements which are common in both sets. These are 5, 6, 3, 4, 1, 2. Set B have elements 3, 4, 5, 6, 7, 8. and set C have elements 9 and 10. A intersection B intersection C, A intersection B, B intersection C. First we have to find B intersection C. B intersection C have elements only, this is set B and this is set C, and these have only these two elements in common. We shade them with red color. This is B intersection C, and A intersection B intersection C is also a so only this portion contains common points of these three sets. Next we have to write here elements 3, 4, 5, 6, 1, 2, 7, 8 and 9, 10. But here we observe that A intersection B, we have to find first A intersection B. So we color A intersection B. Here these 5, 6 are in set A and set B. It means 5 and 6 are common elements of A and B. Next we have to find intersection C. So we observe that 5, 6 are also member of set C. So this is equal to set A intersection B intersection C. The third part of this same question is the distributive property of union over intersection. A union B intersection C is equal to A union B intersection A union C. We have three overlapped sets A, B and C. Here we have B intersection C. This portion is colored. Now we have to find A union B intersection C. Union contains all elements of B intersection C and set A. So set A have elements 1, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have to color whole set just like that. This is the Venn diagram of A union B intersection C. Next we have to color this diagram A union B intersection A union C. A union B, set A have all elements with set B. We have such colored diagram. This is A union B, and next we have A union C. A union C, all elements of A, all elements of set C. In this way, next we have to find their intersection of A union B, this red portion, and intersection with A union C, this green portion. And we observe that their intersection contain only these elements having elements 5 and 6. We shade it dark, and we observe that elements 5, 6 are both in common in these two diagrams. So A union B intersection C is equal to A union B intersection A union C. Fourth part of question number 2, the distributive property of intersection over union. A intersection B union C is equal to A intersection B union A intersection C. We draw this portion. Common elements of A, B, C and common elements of A, B. We have to find A intersection B union C. First we color B union C. B union C means all elements of B and C. We color them full sets. This is called B union C. Now we have to take intersection with set A. Set intersection with set A. It means all elements of set A which are common with B union C, and these are B union C, and these are the sets common B union C. Because 3, 4 are the elements of B as well in set A. Next, we have to find A intersection B. We write here elements 3, 4, 5, 6, 1, 2, 7, 8 and 9, 10. 9, 10 are elements of set C but not in common with set A and set B. So first of all we have to find A intersection B. A intersection B. A intersection B contains all elements common with both sets. So 3, 4, 5, 6, these are the common elements in both sets. Next we have A intersection C. A intersection C have these two sets. A intersection C have these elements, and their union A intersection B union A intersection C, these contains all elements of A intersection B 3, 4, 5, 6 and A intersection C 5, 6. It means 3, 4, 5, 6 are the elements which are in this complete set, and the same function here 3, 4, 5, 6 are the elements of this set. So we can say that A intersection B union C is equal to A intersection B union A intersection C. And that's complete our question number 2.